Yeah, it's Keith Tamburri, the Assistant General Manager, Ops Manager of the Ropos system for the Canadian Submersible Facility, or CSSF. Ropos stands for the Remotely Operated Platform of Ocean Sciences. It's been in the hands of most of the group since 1986, and in 1994, I believe, it became the Canadian Submersible Facility. 3,000 volts powered down the large umbilical, 1-inch umbilical, to power a hydraulic pump, and then most of our actuators are hydraulic. So along from that motor feed, we also send down 3,000 volts high voltage to power all the computers and the peripheral and lights and things on the sub. So there's two main feeds going down the large umbilical, and then we use 2 fibers. We have 5 in our umbilical and in our slip ring. So we have one set of fibers, which is a dual redundant feed for the control. It auto switches if we lose one. And then we have another fiber which handles all of our high-speed Ethernet traffic. Before we had a cage system, which had an armored cable down to a cage, and then it had a synthetic cable from a cage out to the sub. And that one, if it draped across a smoker, it would melt it, and we would have to recover and do a retermination of that cable. For here, with this cable, the way we float it and everything, we don't run into those problems per se, but we do run into problems locally, like with our arms and stuff, and not putting the manips right into the hot water, trying to keep like our high temp probe or the probe of the device that's going to be sampling it. Try to keep it remote. One of the things that we did in the past with our cage system was we used to hang things off. We had the capacity to hang larger, thousands of pounds items off it. So when we changed from a cage system to this live boating or free swimming ROV, we still wanted to keep that capability because quite a few of our clients used it. So we came up with this through frame lift system on the sub, which transfers the load from the umbilical directly to a subframe within the ROV. So the ROV isn't actually lifting up the heavy package, but this through frame lift subframe is, which is attached to the umbilical and this spreading plate on the top of the sub. So the capacity for that is technically 4,000 pounds, but we have to take off a few hundred pounds for the package that we put on underneath the sub to attach to that weighted client package. So I think it's somewhere around 3,600 pounds through frame lift capacity. That's dynamic. We have rated that for dynamic loading up to sea state 5-6. That is limited by the amount of vertical thrust we have. So that limit is around 400 pound package that we can float. The fetch, it was really marginal, right on the line, because I think it's around 400 pounds in water. So we basically treated it like a heavy package, where we full vertical down the whole time, give our cable a lot of deflection, and we landed them on the seafloor. Now the thing about the fetches were that Dana wanted to have them in very specific locations so that they were all relatively line of sight, so that they can all range and ping on each other, because they're looking for very small plate movement, right? And that's why they just keep ranging on each other to see if there's any disturbances, I think both laterally and vertically. They've done it acoustically in the past, but now they're looking at optically controlling the ROVs. So we've actually done a couple projects with instruments using an optical communication link successfully. But I think this technology is to talk longer distances acoustically.